Hello. How many people?
Programming workshop.
Yeah.
Yes.
Oh, look, more people.
So, Unity workshop?
Yes. Okay, how many people are here for the workshop? That's a lot of people. Okay. So we'll be starting now. I'm Conan, one of the programming officers. That is Kyle. He will be helping you if you need help. And I will too. So basically, Unity is written, or the scripts in Unity is written in C#. How many of you are in ICS 31? Oh. So it's kind of different from Python. Like, there are a lot of differences, so I guess you'll be learning a new language then. Anyway, this workshop will be about the basics of how to use Unity and some of the basics of C#. Basically, if you haven't already downloaded Unity, you should download it right now. But I'm sure most of you have already downloaded it because I made an announcement 12 hours ago. We will make a new project and create a game object and add a script to it, which will print stuff to the console. And we will also change an object's color. And yeah. So what is Unity? Well, it's a game engine that a lot of companies use to like make both 2D and 3D games. We can use the personal version for free. There are other versions that if you like make a lot of money, you have to pay a certain amount each year.
Unity is used in both professional spaces and largely known for its heavy use in indie, but it has a free student version and a lot of pretty good documentation. So yeah, a lot of classes use it too, so that's why we teach it.
But it's not open source like Godot.
There's some black box things that are nonsense. Most of them make sense.
Anyway, so everyone has it installed, right? Okay then. So first, let's create a new project.
This is a workshop format, so we'll be doing this in parallel with anyone. If anyone has questions, I'll go around and try to help with any issues you have.
Well, some of you will have like this UI, and some will have like, or I guess, did we not update Unity Hub?
Unity Hub, if you launch any version of Unity and you have Unity Hub installed, it'll just go to that.
Yeah, but there's a new version that we didn't install.
That was like from today. It's very good.
Anyway,
Regardless of what you have, just make a new project. If it gives you the option, set it to 2D, because we're going to be doing 2D things.
so here you just put whatever name you want. I'm gonna put Hello World because that's what it said in the slides. If you have Unity Hub, you can pick which version. I recommend using the latest version, and you can also change the directory of where to save it.
One note about Unity Hub, it's a piece of software to let you manage multiple versions of Unity. So if you have like an old project in one version or a new project in another, you don't have to manage that yourself. You just click on the project.
And we'll be using the 2D template for today. Obviously, if you're making a 3D game, you would use the 3D template instead. If you have a newer version of Unity Hub, it's this part right here where you select which template to use. For the older version of Unity Hub, it's this drop-down menu. And then you just click Create Project and wait for it to load. Any questions? Does anyone need any help?
It's taking a while.
Yeah.
Unity does a lot on startup because it's like a whole engine with a lot of inner workings. When you write scripts for it, you're literally just providing a small piece of the puzzle that it'll run for you. In fact, when you write your own script, it doesn't just execute automatically. There's a step you have to go through and follow its pattern of objects and components in order to actually run anything. So it's just setting up a lot of that for you. So it's slowing the machines as well. That's what it's doing.
Okay. Once you create a new project, it should look like this. If it's the first time, it'll look like this, but I would recommend that you change the layout to tall. You can go to like Window and Layouts and then click Tall, and it will look like this instead.
There's a lot to look at and a lot to parse, and if you don't know what's going on yet, know that most of it's useful. Unity's UI can be changed how they want, but just so we're on like the same ground, so we can all look at the same thing, we're just going to be presenting in tall format.
So you'll notice that when you create the scene, it automatically generates some things for you. It creates this thing called sample scene. A scene is what it sounds like, just a scene. There can be multiple scenes with like each with different things in them. And later we'll be showing you how to use multiple scenes and change between them, but for now we're just going to stick with one scene. And there's also main camera. This basically determines what shows up in the game. So when you click on this tab here, this is basically what you will see when you start the game. There's also going to be an assets folder and a scenes folder. Inside the scenes folder should be the sample scene. So each scene is managed by its own file. And there's also a packages folder which just has a bunch of stuff that Unity will provide for you. Does anyone need more time waiting for Unity to load? Okay. So first we're going to show you how to print to the debug console. But to do that we need an object and to add a script to the object, because you can't exactly just run code by itself. You need something for that code to be attached to. So what are game objects? Well, they're just containers that you put components in, which are basically the scripts. So like you can have a transform component that's basically the script that determines the position, rotation, scale of an object. There's also a component for sprites called sprite renderer. And components also control the behavior of objects. So not just like how they look, but also like what they do. Do they move? Are they affected by gravity? That kind of stuff. And when you write scripts, you're basically making your own components. So first, let's create an object. So you can right-click inside the hierarchy and you go to create empty. You can also create a game object from here, but I like it better here because it's easier for me. You can change it to whatever name you want, like object 1. If you notice, there's like nothing here because object is just an object. There's nothing about it other than its position, rotation, and scale. Unless you give it like a sprite, it's not going to show up. But for now, since we're just printing to the debug console, we don't need that right now. So next we're going to be creating a script. You can create a script by going to the project tab and then right click, go to create. Oh, first, does anyone have any questions? Okay, so you go here, you right click, you go to create and you click C# script. And here you can call it whatever you want. I'm gonna call this one printing. Just make sure there are no spaces because you can't have spaces in the.
Something a little unique about the Unity system is that when you have a script and there's a class inside this script, the name of the file and the name of the class that it associates have to be exactly the same. You can't have spaces in class names in C#. So you have to format it nicely so that will work a variable, anything in C#.
Yeah. When you double click on the script, it should open up the text editor that you set it up to use. By default, it's Visual Studio. If you don't like that, there's a way to change it, but I forgot to check how to do that. Anyway, on this computer, we have it set up to use VS Code instead, because Visual Studio might be like too heavy for some people. Does anyone have any questions? Okay. Once you open it, you'll notice that it will automatically generate some code for you. I won't go into detail about what all of this means because that's a lot of information to tell you, especially if you like don't know anything about programming. But basically, start is called when the game starts running, and it's only called once on the first frame. update is called on every frame. So there's also a third thing you can put called awake. Awake is called in the beginning before start. Awake isn't generated by default, but you can always add it in yourself. And after awake, there's start, and then after that, it's update every frame. Also, don't use infinite while loops if you know what those are. Instead, just use update as a loop, I guess. You might be wondering why you want to use awake rather than start. Awake is called before start, and it's called for every single object, every single active object before start is called. Which means if you have like something that you have to set up in awake, and then in start, if you want to access another object, you know that their awake has already been called, so you won't have to worry about script execution order.
So it's like the pre-setup to the setup.
Yeah, kinda.
A common way to use it is that awake is supposed to be for setting yourself up and everything that you need, and then on start you get references to other people, because once everyone's start gets called for everyone's awake. So on each game object, awake is called for every script on that game object.
So if
game object start is called for every. This is an image on Unity's documentation that shows how your code, the update, start, awake, and other functions exist in Unity's internal loop of everything. It can be helpful for debugging, but this is just showing what goes on internally in Unity. This is why you can't have an infinite loop, because you just stop the entire thing processing your loop, and all of this can't continue.
Yeah. So there's a lot of stuff because, well, there's physics that is actually independent of frame rate. And yeah, so it goes to awake, start, and update, and then it goes and it repeats every frame.
Much of it you won't have to deal with on a day-to-day basis. Most of your logic will be on awake, like start, awake, update. Mostly on because that's like the game logic part of it. But if you need things to happen, say, independent of physics or before or after physics or on UI calls, you can figure out where to do that.
If you're using physics, you should use fixed update instead, but we'll talk about that in a later workshop when we go over physics. So here's an example of what a script would look like. See, you have stuff in awake where you set up the player name, and here in start you're looking for another object and doing stuff with it, and then you just randomly set the color in update. So we're going to output some text to the debug console. So in start, we're going to put debug.log and then parentheses and then in quotations, Unlike Python, every single statement has to end in a semicolon, and instead of having a colon with indentation, we're using curly braces instead. So you can put whatever you want inside here, and it should print it out in the console. If you notice that is in quotation marks, that is a string, and it's basically like a string of text, basically. instead of it being like code, it's the word itself. And in Unity, you can run the scene by clicking on this. Oh, right, I forgot something.
That's the room. What went wrong there?
Yeah, what did I do wrong?
Say more on that. What happened? I heard it didn't attach, so.
You didn't attach it to the object.
You're right. I forgot to add the script to the object. Like I said, code doesn't just run by itself. It can only run when it's attached to another object. So you can attach scripts by just dragging it here, or you can click add component and searching for it. And there's also like all these components that Unity provides for you, like physics and rendering components. So now that our object has the script attached, when we click this button, the play button, it should print out. And it does right here.
A little small to see, but in the lower left corner.
Yeah. If you click on it, it'll pop up, and I recommend that you drag this and put it here. So if you need to have if you print out multiple lines in the console, you can see all of it. So if you run it again, it should print out multiple times. You can turn on clear on play, which makes it so that whenever you press play, it clears it and prints out a new line. You can also do clear on build, which is whenever you build, it should clear everything. And there's also a clear button that just manually clears everything. Okay, what's next? So comments. Basically, whatever you put inside the comments, it's not code. It's just there so that you can understand what you are typing and just communicate with other programmers if they are on your team. So for example, this is a comment that's generated when you create the script. It's not code, it's just there so that you know what it does. You can also type your own comments. So here you can put this prints out so that if you have someone else on your team, they'll understand what this does. It's really helpful if you have a lot of code, because you might get mixed up on what it does. Even if it's your own code, after a week of not looking at it, you will forget what you just did. Yes.
I can't find a way to look at the console.
You can also have multi-line comments like this. Basically, everything between this is a comment, and you can have multiple lines of it. So everything between these. Usually you would use this if you have too many words to put on one line of comment, because it's not that good if you have to scroll horizontally. So actually this, I probably shouldn't put that there. I should probably put it above, but whatever. Yeah, normally it shouldn't be this zoomed in. I just have it like that, so it's easier for you. It's easier to see, but this should be fine. Anyway, next. All right. So if you add in awake, and in here you print out awake, it should print out before and if you have it print out something in update, it should print out every frame instead. So if I press play, what would it print out? Anyone?
Awake and to update repeatedly.
Well, let's see. Yeah. So first it prints out awake, and then and then it starts printing out update every frame. Any questions so far? Yes.
How do we get to the screen where we see what it's printing out? Is
Oh.
that on the right side?
It's on the bottom left corner. If you click on that, then it should have then something like this or something like this will pop up, and then you can drag the tab to the side. Any more questions? Okay, moving on. Okay, variables. So, unlike some programming languages, variables are statically typed, which means you have to tell what type of variable it is before you get to use it. So for example, if you have a variable called foo and you want it to be a string, you have to explicitly say that it's a string. And once you do that, you can only use it as a string. You can't like say string foo equals 3, because 3 isn't a string, unless you put in quotation marks. Same thing with int for integers and floats for, this is incorrect. Floats for floating point numbers, bool for true and false. So unlike Python, true and false are in lowercase. I don't know why they capitalize it in Python, and I don't like it. There's also visibility, which determines whether it can be accessed in like a different class. For now, we'll just cover just the type. So you'll notice that for float, I put an F at the end, because in C# there's 2 types of floating point numbers. There's floats and doubles. Double is just like a precise version of float, but if you put an F, it's considered a float instead. Unity uses floats exclusively, so that's why you have to make sure you're using float instead of double. If yeah, if you use double and you forget the F, Unity will yell at you. Yeah, you can store strings in a variable and use it inside debug.log instead of just typing it out explicitly. So like, if I type string and then woohoo equals yay, and then I put woohoo here, it should print out yay every frame. Also, you should have your variables be named so that you know what it is. Don't like just call it X and Y like in math. Yes.
If you make a variable in, say, like the start section, can you also use it in update or no?
No. When you create a variable inside curly brackets, they don't exist outside of it. So if you want to have a variable that is shared between all of it, you can put it outside here. We'll go over that later. So when I run this, it should say yay every frame. Any questions? Okay. Yeah. So, visibility modifiers. If you have a variable that is in this area outside of the methods, these are called methods, by the way. If you have a variable like here, you can set their visibility, which determines if stuff from outside this class can access it. There's private, which means that you can't access it from outside. You can only access it inside this class. There's public, which is the opposite. It can be accessed from wherever. And it also lets you access it from the inspector window, like this. We'll talk about that later. And if you don't have anything, it's considered internal. Internal is kind of like private. There are some slight differences, but I don't remember what they are. So you can create a public variable and it should appear here once it, yeah. So if you, so public variables can be accessed by the Unity editor. I don't recommend doing this if you intend for this string to just be used inside here. Instead, I would change it to something like this, which is which still lets you like access it here, but like I don't want to, for now I'm not going to explain what it does because that's in another workshop. So for now I'm just going to leave it as public. But I recommend that you use serialized field instead. So now you can just type whatever, and it should assign it to this variable once the game starts. And once I start it, it should print whatever you put here. Any questions? Yes.
Can I just see the code you wrote to make a public variable again?
Yeah. Public string and then the name of the variable.
You only put public if it's outside of the function. I just put yeah. No, after the first press. So in the class. Wait, Kevin.
Hmm.
So you can't declare public variables inside functions?
No,
What was the
because you can't like access it outside.
Okay, so it's not so it's just like flagged as redundant.
Hmm?
Like it's flagged as redundant automatically.
I don't think it will even let you do that.
In C#, there's a concept called scope. Whenever you make curly braces and you declare a variable inside those curly braces, they cannot be accessed outside those curly braces. So that's why we generally, when we make public or private variables associated with the script, we put it at the highest level so everything in the script can see those things. But sometimes we make a variable inside a function, the function has curly braces, so those variables are only visible inside the function and not outside of it.
Yes.
So to make the variables displayable outside of the script, like so you can manually edit it, like only serialized field does that?
Serialized field just lets the inspector window access the variable, but if I make like a second script, I won't be able to access the variable.
Oh, okay, so only the inspector can't. I mean, it can, so public, even with public, it can still let the inspector.
Yes, either public or serialized field.
Okay, so serialized field is just safer then.
Yes. Moving on. Accessing other game objects. Yeah. So when you have multiple game objects, sometimes you want one script to access another one. For now, we'll be using GameObject.find, but I highly recommend that you never touch this ever because it's kind of slow.
Yeah, at the very least, don't do it every frame. It's okay to do
Yeah.
slow things like once in a project, but don't rely on this for all your object grabbing needs.
Yeah, so if you have to use it only in like start or awake. Or start, I guess. So this is basically how you use it. You can create a game object variable, and that stores game objects. And GameObject.find, you put in the name of the object, and it should return the one with that name. So like here it finds one called Cave Goblin and stores it into the variable called enemy. There's also get component. So once you have the object, you can access its scripts or components using this method called get component. So for example, if you want a sprite renderer, which is the component that controls what an object looks like, how like with sprites, then use enemy.getComponent, and then inside angle brackets you put in the type of the component you want, in this case sprite renderer, and then empty parentheses, and it should give you the sprite renderer. If it doesn't have this component, then it'll return something called null, and it's basically like none in Python. It basically means there is nothing. And if you try to do stuff to it, it might cause problems. So make sure that you have the component before trying to get it. So you can create a sprite by right-clicking the hierarchy, and then going down to 2D object, and then clicking sprite. And it should look like what the first one was when you create it, but it'll also have a second component called sprite renderer. Alternatively, you can create an empty game object and then manually add the sprite renderer, but this way it's faster, going to 2D object and then sprite. So after that, you'll see all of these things you can change. For now, just change sprite to, you scroll down and choose UI sprite. You can change it by or you can change it by clicking on this circle to the right of the window. And if you look in the game, you'll see there's a square there. If you want to, you can make it bigger so that you can see it better.
You can scroll to
Yeah.
change.
Or you can just type in like the size manually. This is inside the transform component, not the sprite renderer, the scale part. So yeah, inside here you can like do stuff like move it around, or you can also change the scale from here. And if you click on the game tab, you'll be able to see what it looks like when you play. Yes.
So this is a bit more of a complex question, but for background sprites, is it more efficient to have like one asset that like you reuse a bunch of times, or to have like just a pre-built asset that is like the level?
Can you repeat that?
So for the background, like what's the like how do you normally make your backgrounds in 2D games? If you
It depends on how many things are in the background and if you want like parallax scrolling. Usually it's better to just have less objects, and if you have to like change the sprites, just keep using, or I actually don't know whether it's faster to change the sprite or like use multiple.
What was the question?
So for the background, is it better to have like say like one sprite terrain that you reuse multiple times, or you like have to pre-build the sprite terrain, and like you just use it like once. Like which one would be more efficient?
It sounds like between your two options, one has one sprite and one has many. Though in general, sprites are inefficient because they're kind of their own image floating in space. The real way, well, not the real way. If efficiency is everything, I think you probably go and do like canvas space stuff where you render images directly to the screen as opposed to saying, here's an image in the world. But in general, if you can set it up beforehand, Unity can optimize a bit about how it works. So if you just set up a bunch of objects in the scene and just move a camera over them, it won't have to do much.
The problem with Canvas is that Canvas only renders on top.
That's true. There are limitations to Canvas. It's not a catch-all.
Okay. So yeah, you can also change the name of the object if you want. And that's setting up. Okay. So now, okay. So now let's change our script. So inside start, we will use game object dot find, and then whatever you named your object. So I just called mine box. So I'll put box here. And I need to store it somewhere. So I will create a variable called box. You can either just declare the variable first, then assign it, or you can do both on the same line. Normally I would just do it like this, but since it's zoomed in, I'm doing it like this so y'all can see it better. After that, we want to, so right now we're trying to change the color of this, and you can change the color by doing this.
Generally, when you're in Unity Inspector, if something looks clickable, it is.
Yeah.
And then you can edit it that way.
But right now we're trying to edit it from a script. So you'll notice that this component is called Sprite Renderer. So you can access that component with box.get component, and then inside the angled brackets put Sprite Renderer with no spaces, and then parentheses. And you know, I want to store it somewhere, so I'll just make a variable for it as well. And you can call it whatever you want, like SR or renderer. Any questions so far? Yes.
Why did you write sprite renderer renderer?
Huh?
Why did you write sprite renderer renderer?
I'm creating a variable called renderer, and the type of that variable is a sprite renderer.
But it was to store the sprite renderer.
Yeah.
Because if you make that call, it returns you that object only on that one line. And if you don't save it anywhere with like equals operator, it just disappears after that line.
So,
You have a question?
Yeah. So like, you might have said it, but I kind of got confused. Like, what does like the get component method for the sprite render, like it just gets like what does it exactly do?
So box is a game object.
Yeah.
So it's looking at its components and looking for the one called sprite renderer.
Oh, okay.
So you'll notice that it has two components, transform and sprite renderer. We want this one because that is how we change its color.
I see. So by the same token, then you could, if you attach scripts and they're called like something like say like example, like or like a script called example, then if I put example inside get component, it would get that. If
Yes.
A script is a component, get component of type your script will work.
So like if you want to, say you have another script on here and you want to access the printing script, then you would have get component and then inside you would put printing instead. And that's how you would access stuff from this script.
Though there are limitations to this. This only gets the first component it finds that matches that type. You could have many components on an object. So if you have multiple sprite renderers, I actually don't think that one's allowed because you can only have one renderer per object.
Yep.
But if you could, it would only get you the first one. There are other types of functions you can call, like get components, plural. The documentation tells you all different like variations of this. So it's documented online if you want a different use case. Just do that.
Okay. And to access the color, well, it's called color, unsurprisingly. So to access that, we would put renderer, because that's what we called it, dot color. And to change the color, we would just use equals and change it to whatever color you like. So let's do blue. So we can do color dot blue. And once we hit play, it should change to blue. Yeah.
Can I see the code again? Oh, okay. Thank you.
There's a lot more colors than just blue, but with VS Code, it doesn't like show all of them. If you have Visual Studio, once you like click color dot, it should like give you a list of all the colors or all the preset colors. You can actually create your own color with like, but we'll go over that sometime later, I guess.
For now, it's just shorthand colors you can do. So you can do color dot, most common colors exist.
Yeah, so you can also do like red, and it should change to red this time. Fun fact, there's also color dot gray for both A and E.
Oh. There's language differences.
Yeah. So let's, and yeah, that's
The end of the workshop.
the end of the workshop. Any questions? Yes.
Will this line be available?
Yes. Okay. So the next workshop, we'll be talking about frame rate independence, where we'll be doing stuff with regards to seconds instead of frames. We'll be talking about vectors, transforms, global transforms, and input, and some other stuff. There's documentation, and I highly recommend that you use it, because, well, if you just Google something, you'll most likely end up being directed to the documentation, and that's how I found out a lot of stuff about Unity, because I stopped going to workshops last year. And there's the scripting API, which basically tells you about like what stuff is in each component and what stuff you can access and how do you use them. And there's the manual, which is less about code and more about like stuff inside the Unity editor. Or you can use Google, that's what I did, but usually that just directs you to the Unity documentation or other Unity like forums and stuff. And there's also tutorials, and I'd recommend that you don't use the really old tutorials because they're kind of outdated. So at least 5.x, I don't know what that means anymore.
At least version 5.
It's before they switched to the year.
Yeah.
Yes.
Duh. And here are some documentation links.
Just for stuff that we mentioned in this workshop.
So like, it goes into more detail about some of the stuff I mentioned.
Oh, and a useful part of them, they give examples on how to use these things. So if you don't know how something works, then you can just go
Yes.
there and see an example of it supposedly working.
Yeah, that is it.